You must have heard about the cyclone Amphan that made landfall in the state of West Bengal a few days back and created a great deal of devastation and destruction. It also created strong gusts of wind and flooding in that particular area. So Amphan was a tropical cyclone which originated from the Bay of Bengal. So what is a tropical cyclone? Let's break down this particular term. Tropical means occurring in the areas near the equator, but not exactly the equator. The areas of 8 degree latitude to 15 degree latitude on both the north and the south direction of the equator are called tropical areas. And cyclone, when we are talking about cyclone, comes from the Greek word cyclos, which means the coiling of a snake. So you must have seen the satellite pictures of Amphan and the swirling of clouds, that particular image that gives you the image of a cyclone. So let's march forward and dig into this concept of how cyclones form and what is the mechanism of a cyclone. So in order to grasp this particular concept, let me tell you a very simple example. It is just like a heat engine. It is a very big and an enormous heat engine which transmits and which disperses the heat from the water into the air. And cyclones are the biggest heat exchangers in the world, which makes, which brings about the state of equilibrium of temperature around the earth. So it maintains a state of homeostasis. You can say that it acts as a homeostasis for the earth. Now moving forward, before we go to the concept first, let me give you some scientific principles that will be involved in this particular video. We'll be looking at the latent heat of condensation. This is a very important concept when we are talking about cyclones, and this is the only concept, this is the only phenomena which makes a cyclone work. So the latent heat of condensation, latent means which is hidden or छुपी हुई जिसे हम कहते हैं. So latent means which is hidden, and something which gives out heat becomes cold. So when the condensation of water occurs, when it condenses, when the water vapor condenses to form small tiny water droplets, it releases out some heat, and that heat it converts itself into mechanical energy, and it creates that strong winds and the upliftment of water vapor further to the tropospheres and even beyond the troposphere. Now, the second concept that we will be dealing with is the conservation of energy and mass. So students, in this universe, everything which has energy or anything which has mass, it will follow this particular concept of conservation of energy and mass. So we have already studied that energy cannot be created nor destroyed. It is just converted from one form to the another, and same goes for mass as well. So in the same way, when the winds are moving, when the winds are meeting towards one another, they are running towards one another, it will create an upliftment force. And similarly, when there is a meeting of wind in the lower strata of the atmosphere, there will be a dispersal of wind in the upper layers of the atmosphere. So this creates a cycle. This will be very, very important when we will be discussing about this particular cell. Moving further, let's move on to the factors responsible for the formation of cyclones. Now, the first and the foremost factor is the warm water. So cyclone occurs during the months where the season transit from one to the other. Let's take for example May or April. So April to May, this particular season, we are transiting from winter to summer, and during September to November, we are transiting from summer to winter. These are the months where we have this particular belt called ITCZ, which is located over the body of water, especially this Bay of Bengal. And this, along with other factors, create the perfect conditions for the cyclone to work. Now, the first and foremost condition that a warm water body should be there, and the water should be having a temperature and an average temperature of more than 27 degrees Celsius. Because a water body having a water temperature of more than 27 degrees Celsius will have more latent heat, and therefore the cyclone will get more energy to work with. The second factor that we have is low pressure. We have already known that things expand when they're heated. So when there is heat, when during this season of May, you must have already seen it is getting pretty hot nowadays. So what is happening is there is an area of low pressure that is developing in the Bay of Bengal. and cyclones develop out of such low pressure areas or instabilities. So you can see we have some thunderstorms, we have some heavy rainfall, cumulonimbus clouds developing in near the water bodies, and due to that rising of the air, a low pressure area is created. So when air is uplifted because of higher temperature, the water gets hot and the air near that water it lifts up. And because of this upliftment, there is a small vacuum created near the surface, and in order to fill that vacuum, air from all other sides they rush in. This creates the phenomena that we call as winds. So these winds move in from different directions to fill this particular little void. Now when the wind is moving from one place to the other, we must not ignore a very important phenomenon that is called the Coriolis Force. Now let me explain very briefly what Coriolis Force is. Suppose you have to go from here to Delhi. You are going from Sonipat to Delhi. So you will take a straight road which is going straight away. You can take a straight path, and suppose we are talking about giant celestial bodies like the Earth. So if we are air, then we do not have to take a straight path, but we will be taking a curved path instead. So we will be moving from our place to Delhi, but the path that will be following is that will be a bit curved because of the rotation of the Earth. That is very, very important over here. So Coriolis Force happens because of rotation of the Earth. If the Earth stops, and the Coriolis Force will also stop. One more phenomena associated with Coriolis Force is there. That is near the equator, Coriolis Force is completely absent, and Coriolis Force is maximum as we go towards the poles. So when we are talking about the 0 degree equator, then Coriolis Force is absent near this 0 to 5 degree range, north and south, and right from this 8 degree latitude north and south we get to have some corrosive effect. Now due to this corrosive effect, what is happening is that the winds, when they are moving from one direction and one place to other, they are curved, and due to this curving, what happens is they circle around one another. So when two winds are meeting, they do not meet head on, but they curve themselves in a spiraling way. So this is how it happens. Instead of winds going head on straight, they are going in a spiral, and that creates the necessary action, the rotatory action for this cyclone. Now one thing you must also note that I have made this in an anti-clockwise direction. So you must also note that anti-clockwise cyclones revolve anti-clockwise due to Coriolis Force in the northern hemisphere, and they revolve clockwise in the southern hemisphere. So this is one more thing that you have to grasp here. The next is the latent heat. Latent heat, we have already talked about the latent heat of condensation. This gives the necessary force, the necessary mechanical energy for the cyclone to work. We will be dealing with this later when I am explaining the mechanism. Then another important is low shear. As I have told you, when a hot air it warms up near the surface and it rises, so it creates an area of low pressure. This is the area of low pressure. So directly above it, there will be the upliftment of wind, of basically you can say the air current. So the air current will be uplifted, and due to the upliftment, a small vacuum will be created. But cyclone will only form when there are very less cross-sectional exchange or very low wind speed in the upper layers of the atmosphere. So shear means the perpendicular movement of air at various levels of the atmosphere. This is again very, very important, because we have to have a columnar upliftment of the air current and also the moisture that it is carrying. Now one more thing, warm water provides the necessary moisture to the cyclone, and which is again very, very important to release that latent heat which is present. Now moving on, let's discuss the mechanism of this particular cyclone. Let's talk about Amphan. Amphan is a Thai word. So it is a Thai word which means sky. So we have many different words that have come up. You must have heard about Nigar, you must have heard about Katrina, you must have heard about Gustav, you must have heard about, you will be hearing about Gati and Gulab in the near future. So we will be discussing how these are named and why they are named. Cyclones, why the naming is done. This is again very, very important. Now when we are discussing about the cyclone, again let's start with this warm sea and ocean. Now this warm sea and ocean has a temperature of more than 27 degrees Celsius. And let's say over this particular area, due to excessive evaporation and high temperature, the air is uplifted, and due to this upliftment it creates an area of low pressure. And as the water vapor is going up, and the air current is going up, the air from other sides are also rushing in, which is known as winds. So here we have the southwest winds, and we have the northeast trade winds. These are the winds which rush in, and this is the belt that is called the ITCZ, that is the Intertropical Convergence Zone. It is nothing but a imaginary belt where the two winds from different directions meet. And when they are meeting, just make sure on equator they can meet head on because of the lack of Coriolis force. But when we are talking about when we are moving from equator and up towards the poles, they will swirl around each other in a spiraling direction. So ITCZ is where the two winds are meeting, the surface winds are meeting, and when ITCZ is present over land, so there is no moisture, so the cyclones cannot form. But when this ITCZ during transitional months, now during transitional months, let's have a look at where the sun is. So the sun will be located at in around June. The sun will be located at the Tropic of Cancer. So now around May, the sun will be somewhere over here near Nagpur, right? So this ITCZ will be somewhere around in Bay of Bengal as well. So this ITCZ will provide the necessary Coriolis force as well as the moisture which will be needed for the development of cyclone. Therefore, Amphan was created. Therefore, Amphan got its energy from. Now, what happens is when the winds are rushing in from different directions, it does not meet head on, but it creates a spiraling effect. So it is spiraling and then it goes up. Now as it goes up, there is condensation of water vapor, and as I told you, something which is getting cooled will release heat, because heat is nothing, cooling is nothing but the absence of heat. So when it is releasing its latent heat, when water is releasing its latent heat, what is happening is it is providing that energy into mechanical energy, and that will uplift those water vapor even more and lead to sudden formation of clouds. And these clouds will be so high that they will touch the troposphere, even they deform the troposphere. So as you can see, there is a slight depression in the tropospheric layer as well. Now, when we are talking about the cyclones developing from instabilities or small thunderstorms, that is very true. So, cyclones develop from small thunderstorms and instabilities, and provided the right conditions, these all 5-6 factors, a cyclone is developed. Now, the winds are spiraling. Now, the winds have come from both the directions, and they are spiraling like this towards the tropopoles. Now, one more thing happens over here is that is cooling and condensation. Now due to condensation, again the air when it reaches a particular height, it cools down and it becomes heavy. Now when it becomes heavy, it starts to sink again. So this cooled air sinks in this particular column and also through the sides of this particular body. And when it again rushes in, so this creates a cycle. So again the wind is going up in a spiral direction, cooling up near the tropopause in the troposphere, and again cooling down and coming back. This creates a cycle, and one thing which is happening over here is this cool dry air, when it comes down, it again picks up the moisture from this warm water body and again goes up with the moisture, forms the cloud, again comes down, picks up the moisture and again goes up and comes down. So this acts as a lifting force, and it is such a force that every 20 minutes the cyclone it releases so much of energy every 20 minutes that is equivalent to a 10 megaton nuclear bomb. That is a great deal of energy that a cyclone has. Now, due to this reason, this low pressure area is so calm that even the sea water is uplifted a bit, and when the cyclone is moving towards the land or towards any particular direction, this water, when it subsides, it creates a series of waves, and when it reaches near the land, it creates huge tidal waves that we call as sea surge. Sea surge leads to flooding and drowning of the low-lying areas in the coastal cities. You must have seen all the videos and pictures of the Kolkata airport where there was heavy flooding. That was due to the sea surge. Now, what is happening is not just this cell forms, this circular formation of air, this circular flow of air forms. There are many small circular air of flow that comes into the picture. So what happens is we call them rain bands. So these such rain bands form near the cyclone. That gives a picture of that swirling effect to the cyclone. So when we are talking about that swirling effect, we must note that this cold air also comes down just beside this eye wall that I'll be telling you more about, and this cold air also goes up again and creates that circular flow. This warm air which is coming in, it is getting uplifted and it takes the moisture with it again, and this forms the eye wall. So this is the eye where there is a area of low pressure where the air is going up. Then there is subsidence of this cold air just beside this wall, and this is an area that is very, very calm. We can have very rough seas in this particular area just because of this upliftment. But the area, there will be no air current, there will be no wind, there will be no devastation in this particular area that we call as the eye of the storm. You must have seen this in 2012 movie, right? Or Day After Tomorrow. Many movies are there which show this particular concept. And the most devastating part of a cyclone is the eye wall. So over here, when the latent heat is released, that heat transforms and generates the wind and the clouds that are necessary. So it ropes in the clouds due to centripetal force, and due to that centripetal force, the clouds starts to swirl around it. Okay, and now what happens is the maximum amount or the maximum velocity of the cyclone will be in this eye wall. So whatever damage needs to be done, that will be happening over here. Now, when a cyclone approaches the land, like let's take example of Amphan. So when Amphan approached the land, the coastal area of Bay of the West Bengal, what happened was its onset was marked by heavy rainfall. Then the eye wall approached. The eye wall devastated the city with gusts of wind and nearing to I think about 212 kilometers per hour. So this was a super cyclone. We have categories of cyclones from category 1 to category 5. So category 5 is the strongest of all, which is having winds more than 200 kilometers per hour. So this Amphan was a super cyclone which was the strongest cyclone, one of the strongest cyclones in the Bay of Bengal till now. And this eye wall, when it approached, it devastated the city. And again, when we had this eye, it was followed by a short, brief, you can say, lapse of rain and wind. And again, we had a devastation due to this particular area of the eye wall. And ultimately, these rain bands brought in heavy amount of rainfall and created a depression. Now, let us recap a bit. Now, when a cyclone reaches a particular coast or a coastline, what happens is it is cut off from this moisture part, and we have already dealt with that. It requires warm water. So we have seen when a cyclone makes a landfall, it dissipates or it falls apart because of the lack of moisture, because it does not get that latent heat due to that condensation and evaporation process. Now when it dissipates, what happens is it leaves a very huge area of a depression, because this low pressure still remains, and due to this low pressure the rain bands approach and heavy amount of rainfall is witnessed for many days. So it is not just that the devastation is happening because of the strong winds, but also flooding will happen because of heavy amount of rainfall that can go on for days. So this is the most strongest phenomena of nature and also the most terrifying and devastating one. Now let's talk about the naming of the cyclones. So there are many RSMCs which are located in different parts of cities, different parts of the world, sorry. And one of the RSMCs that are there, it is one of the hotbeds of cyclone is the Bay of Bengal. We do not have much cyclonic activity in the Arabian Sea, but most of the cyclonic activity is there in the Bay of Bengal. Now, whatever cyclones that are formed over here, they are brought either into the coastal areas of Andhra Pradesh, Odisha, and West Bengal, and eventually they can also move into Bangladesh and Myanmar. Now why does this happen? This happens because of the easterly jet stream, which is again the strong upper air current flow, or a strong upper flow air flow which is happening in the upper layers of the troposphere. And because of this, this whole area, this movement of clouds is being taken towards the land, and this charts the course for a particular cyclone. Now these RSMCs in 2004 they agreed on a formula. There were 8 countries in this particular region who drafted a list of possible cyclones that may come in a year, and this went on for a quite number of years, and later on 5 more countries were added to this list. So now a list of 30 countries, they chart out their list of cyclone names, and these cyclone names are very important. And for India, the agency which is responsible for giving names to the cyclones is the IMD, the Meteorological Department, the Indian Meteorological Department, and they have given some names like, you must have heard about Vayu, which came a few months back, and we had Nisarg, we will have Gulab, Gati, and Amphan is the currently active cyclone over here. Now why do we name these cyclones? Why do we have Katrina? Why did we have Gustav? So why do we name these? This is because there are 2 reasons. One is that one cyclone can breed another cyclone. As I told you, that cyclonic activity is formed because of instabilities, and cyclone is an unstable, or you can say it's a very unstable phenomena, and it will lead to some more cyclones. It can lead to some more cyclones. So when there are 2 cyclones system forming in a particular water body, just like Bay of Bengal, let's suppose it is one more small cyclone coming in this particular portion. So people must be able to distinguish the people who will be rehabilitated, the people who will be affected, even the government agencies, the NDRF, who needs to be informed that with which cyclone they have to be prepared and at what time. So for the preparation purposes, we need to name them so that there is clarity in information and there is clarity in preparedness. That is the first and foremost thing, that is security. So security and disaster management can be done easily. So that is why we are naming these cyclones. Second is easy identification. So when we are talking about the name of cyclones such as Gati, Nisarg, Amphan or Vayu, we are giving them names for the media to be disperse the information quickly and easily to all the people. So suppose there are 2 cyclones, and if let's say suppose the media is saying that the cyclone is approaching, the people might not know that which cyclone is approaching towards which city or which area, and the people may be confused, and that may lead to greater number of deaths and destruction. So in order to prepare ourselves for the upcoming destruction and for making the arrangements for disaster, we need to have clarity in information as well. So this was all about it. So you have to just remember these few scientific concepts, and that is latent heat of condensation, conservation of mass, and conservation of energy. You must have also heard about that when things heat, they expand. So we have the expansion of air and upliftment, and when anything is heated, it becomes lighter and it uplifts itself. When anything is cooled down, it becomes heavy because its density increases, and thus we have the cooling of air, and this breeds a vicious cycle which gives the cyclones necessary energy. So cyclones are basically, you can compare them in thermodynamics. We have a concept of Carnot engines. Carnot engines are basically heat engines. So these are just like that. These are very big Carnot heat engines which transmit energy or which distribute energy all around the earth. So earth has a great mechanism of dispersing its energy, because this particular tropical area, the area from equator to the Tropic of Cancer, that is 23.5 degrees north, and to the Tropic of Capricorn, that is 23.5 degrees south. This is called the tropical area. This area receives the maximum amount of solar insolation, and so heat needs to be distributed to different parts of the world, as we can say, from these lines to the poles. So heat is dissipated from these areas through air currents, through water currents, through cyclonic activity and other sources. So that was all about it. I hope you learned a great deal. Keep learning and be awesome. Thank you all.